just because people have asked and because Cambridge don't consider it their job to put any kind of mark scheme or work solutions online for this paper, I'm going to do part A, the maths section of the 2021 ECAA paper. Again, there's no mark scheme anywhere, so I guess this is now the official mark scheme. I should warn you, I've done this paper ridiculously fast and have not checked through any of it. So, sure. This -3 means division, so I can put it on the bottom, then we can just do normal indices things, add the indices, multiply the numbers, raise that to power there. This over this is 1 over 25, I believe. Nope, it's 1 over 5, because of course this times 5 is that. Yeah, this time this and this take away to get -3, or a 3 just on the bottom. These cancel, so we get this, which is this answer here. Okay, yeah, anyway, this question here is one where we want to factorize first. A big hint that you always give is that you always want to factorize the easy thing first. The thing factorizes very nicely, because now you can look at this and go, well, okay, that's probably going to have one of these terms in it, because otherwise they wouldn't have written the question. And even more than that, you can just cheat and look at the answers and see what it's going to have. It's either going to have 4x plus 1 or 4x minus 1. It's going to have to be a -1 to expand out to make that. And then these cancel, which is good. So we're left with this. We can write this as 2 4x minus 1 over that. We can then just say it's this minus x on the top. Expand it out to get 8x minus 2, and then just obviously 7x minus 2 on top. With the denominator the same, and we get the answer here. Good. Question number 3. So we want to isolate q. So let's move this term over to the other side. Let's combine these fractions. So this time this is 8. This is rp all over 2r. Now that we've got fraction equals fraction, we can flip both over. You're allowed to do that if you just have a single fraction equals another one. You can't do it on things like this, but if you've got fraction equals fraction, you can. Times everything by 3 is going to make that into a 6, and you've got the answer there of D. Good. Number 4. This is good. I'm going to re-upload a video that was on the old channel about this. I know the answer to this as soon as I read the question. Is 4x plus 3y equals 25? Like, I just know that. That's just the answer. I don't need to do any work. And let me explain why. If you sketch it down, you've got a point 4, 3 with a circle going through it, through the origin. Of course, that means this distance here is 5 because it's a 3, 4, 5 triangle. Technically a 4, 3, 5 triangle, whatever. So the equation of this circle is x squared plus y squared equals 25 because it's r squared here. I'm going to write this weirdly. I'm going to write it like that, and then I'm going to substitute x equals 4 and y equals 3 in for one of these x's and y's, and then you get the equation line, which is that. That trick always works, and it's amazing, and I'll put a video on the channel talking about that in more depth. Question number 5. So, okay, surface areas then. So, surface area of a cylinder is 2 circles, top and bottom. Each area pi r squared. R is x over 2 and y over 2, so just be careful. So the surface area of P is 2 lots of pi times x over 2 squared, plus this curved surface around the side, which is pi d is the circumference of this, so that's just going to be pi times x, times y, because that's the height of the thing. It just folds out into a rectangle. So we have that there. Same thing for q, but you swap the x's and y's. Now, apparently x is bigger than y, so if we do this one, take away this one, we'll get a positive difference. But of course, you notice now that pi xy minus pi xy cancels. So we're just left with this. I've also done x squared over 2 squared, which is this, and likewise here. This 2 cancels with this 4, which is going to divide by 2, likewise here. You can factorize out of pi over 2 and just leave x squared minus y squared on top, which is that one there. Now here, just do this one plus this one to get 2 lots of 8 to the power x. These two things cancel. 13 plus 5 is 18. This is a half, divide by 2 to make a quarter. You can write 8 as 2 to the power 3, and you can write as 4 as 2 to the power 2. These things multiply out. This is 2 to the power negative 2 because it's 1 over, and so we have 3x equals negative 2, which means x is minus 2/3. Question number 7. So just pick a number here. So just say p is 100. Reduce it by 10%. Well, that takes it down to 90. Increase it by 10%. Well, 10% of 90 is 9, so that gets to 99. That's the finishing price. So this one is lowered in price. Let's just make q 100 as well. Increase it by 10% to make it 110. 10% of this is 11, so take that away and you get to 99, so they're both lower than the original price. Quite an interesting thing that I recommend doing some extra reading about. Anyway, question number 8. So notice here that all the square numbers are on the end of a row, and when you reach a square, you go to the next row. 196 is square because it's 14 squared, which means it's on the end of a row. And then notice that the way that they're constructing this is that the previous square is over, on top of, a number 2 away from the next square. The next square is 15 squared, which is 225, and so if you imagine this isn't 196, 225 is there, you go back 2 numbers and you get to 223. Number 9, so 8 squared is 64, take away 4 squared is 16, gives you that this distance is root 48. Square rooting, now this is in the ratio 1 to 3, so this is one part, this is 3 parts. Root 48, well 48 is 16 times 3, which is very convenient because it makes it 4 root 3, so you can literally just say this is 4 root 3's, so split into the ratio 1 to 3 makes this section 3 root 3's, and now we can just do Pythagoras here. 8 squared is 64, take away this squared is 3 squared times root 3 squared, which is 9 times 3, which is 27, 8 squared is 64, minus 27 is 37, so was it 37? 64 minus, what the hell has happened there? 64 minus 27 cannot be 37. Oh, it is. How? I've just typed it into calculator. That blew my mind for a second. I have no idea how that's the case, but sure, whatever. Question number 10. So I'm not going to bother much with this. This is 7 parts, divided by 7 for 9, times by 5, times by 2 to make this. They each spend an equal amount, so they have this money to start with, and they each spend x, so let's take away x from each of these, and that's now in the ratio 3 to 1. Now this means that if you times this one by 3, you get to this one. That's what the ratio 1 to 3 means. So if we times this one by 3, we get to that one. So we can set up this equation, expand out, add 3x to both sides, take away 45, divide by 2, and we get our answer. You could have just used trial and error, but sure. Question number 11. So firstly, we want to find the intersection between this and this. So let's set this equal to this, and then rearrange for 0. We get this. That's a quadratic. For core, that's fine. The two roots of this quadratic, if you do one, take away the other, is 8. Now, to find the roots of this, you could do the formula. I'm only doing it this way because I did a Tamura question just like this recently in the same way. Now, this gives you both roots, right, by either plussing or minusing. So the first root, the larger one, q, can be found by plussing, and the second root, p, can be found by minusing. If we just consider q minus p now, what we'll notice is that this minus b, minus b, well that's a plus b, and they cancel. And this plus root minus minus root will be an add now because it's minus minus, and we'll get 2 lots of the root. And so q minus p is just this. Now, of course, q minus p is defined to be 8, so we can put that in there. And we can also say a is 1, b is minus 6, and c is 5 minus c. So we get this here. The 2's will cancel. You can say this is 36, this is minus 20, and then plus 4c. This is 16 plus 4c. You can square both sides. Here you can rearrange, and you'll eventually solve the answer of 12. Quite an interesting question. This one here, so what are the ways to get 10 litres? Well, you can either have 2 litres and then 8 litres. So there are 10 things in total. That's 2 over 10 times 1 over 9, because there's one less bucket to choose from once you've chosen the first one. Or, of course, you can get the 8 one first, and then the 2, which will just be this. So that's the 1, 8, and then the 2. Or you can, of course, do 3 and 7. So you take one of the 3's first, and then one of the 7's, or one of the 7's first, then one of the 3's. Of course, all these denominators are just 90, so all I need to do is do 2 times 1 is 2, plus 2 times 1 is 2, which is 4, plus 12 is 16, plus another 12 is 28. Half that for 14 over 45 would be our answer. You can also do a sample space on that question if you really want to. Sine 60 is root 3 over 2, cos 60 is a half. What's the same as dividing by a half? Well, it's the same as timesing by 2, so we may as well just times this by 2. We're looking for y cubed, so we cube both things. Got to do some binomial expansion here. Root 3 cubed is root 3 times root 3 times root 3, which is root 3 times 3, which is 3 root 3. These red ones are the binomial expansion coefficient, so 1, 3, 3, 1. I'm taking 2 root 3's here to make a 3, and 1 minus 2. And next I'm going to take 1 root 3 and 2 minus 2's, and then 3 of the minus 2's make a minus 8. I'm just going to be so lazy here. 3 times 3 is 9, times minus 2 is minus 18. And then I'm just going to notice, without doing any other work, that minus 18 minus 8 is minus 26, and the only one that has a 26 in it is this one, so it must be that one. Good, you can verify that it does indeed work. This one is kind of interesting as well. The first thing you want to do is construct these two lines and say, this is now a cyclic quadrilateral. This original thing is not, because this isn't on the circumference, but this is. So this angle here is 40, double it to make this angle is 80 by some circle theorem rules. Now, most people here will do some cosine rule, I think, to find these lengths, but there's no cosines in the answers, so we have to play by their games and think, how do we get some sines instead? Well, what you can do is you could notice this triangle here is isosceles, because radius, radius. So if you go straight down the middle, you'll not only break this angle in half to make 40, but you'll also break this length in half to make 3.5. And this looks very promising because we want the radius, which is OR, and we have sine 40 is 3.5 over OR. You can just bounce the 3.5 over to the top, and we'll get OR, or the radius, is 3.5 over sine 40. Number 15 then, so you could do algebra here if you wanted to. The probability of Charlie not eating green is this, which means, well, that's the same as him eating 2 red. So the probability of him eating 2 red is this. There are 9 sweets in the bowl. I'm just going to guess that 6 of them are red, because then I can just very quickly do the maths and say 6 over 9 times 5 over 8. Again, we're not replacing, so we reduce it by 1. Well, that's 30 over 72, which cancels down to 5 over 12. So yep, my guess was correct. If there are 6 red, that means there are 3 green, so I can now just do 3 over 9 times 2 over 8, which is 6 over 72, which cancels to 1/12, and I avoid any actual work there, which is good. Question number 16. So you could do some, this is isosceles obviously, because 45, 45, so this is y. You could do some Pythagoras to work out this is, or you could just walk around constantly with this shape in your head, as I do, because then we can just scale factor up and immediately write down this is y root 2. Now the hypotenuse is the same, so this is also y root 2, which means sine of 60 equals x over y root 2. And I was a bit annoyed about this question. We've already seen sine 60. I was a bit annoyed about this because getting the answer is, unless I'm just missing something, it's just quite annoying. In fact, I realise now that I am missing something. I could have just times by y, divide by root 3, times by 2, and get 2 over, okay, whatever. So I times by y root 2, this makes root 6. I then times by 2 divided by root 6, and then I rationalised by timesing by root 6 top and bottom, and then 2 over 6 is over 3, so it's root 6 over 3. I feel like there are better ways of doing that. Anyway, question number 17, so this is a cuboid. You can build a similar smaller cuboid with these lengths, and it's half of the original, so this is a very weird way of telling you that the side lengths of these are 4, 6, and 2x. And now the diagonal, just by triple Pythagoras, 3D Pythagoras, is just 4 squared plus 6 squared plus 2x squared is equal to root 77 squared, which is of course just 77. I think the only thing you need to be careful of is to make sure you make this 4x squared and not just 2x squared. Of course this equals something that when you take away from that makes that. Divide by 4 and then square root both sides, and you should end up with the answer 5 over 2. Good, number 18. So if we call Cameron's speed just s for speed, Alex has therefore got a speed of 1.12s, and Sam's got a speed of 0.98s. Get out some speed equals distance over time. We know distance is 400 for Alex because he finishes the race. His speed is this, so we can set up this equation by bouncing the distance and doing distance over speed equals time. Now, I didn't want to do this, so I just halved both, and then I halved both again, and then I halved both again, and then I times everything by both top and bottom by 100. And I still didn't want to do this, although it did seem very doable. I didn't want to, though. This is the amount of time it takes Alex to finish the race. So if we plug that amount of time into Sam, because we know Sam's speed, we now know his time, or at least the time that we want to stop Sam at to find out how far away he is, and let's find out the distance that he's ran. So okay, well this over 14s, that bounces up to the top, and we get this. The s's now clearly cancel. I times everything by 1,000, I think, here to get rid of this 1,000. Times by 5 to get this, divide by 14. Dividing by 14 here is easy because you just divide by 7, which you notice makes this 700, then you divide by 2 for 350. And so Sam has ran 350 meters here, which is 50 away from finishing, so he's got 50 meters to go. 19, I have no idea how you're supposed to do this question, to be honest. All I said was, well, let's just pretend m is 5, and let's pretend x is 10. That means that to work out how many kilometers he's gone, like if he's done 5 miles and there's 1 kilometer every 10 miles, which I know is ridiculous, but if that's the case, then he's gone half a kilometer here, right? Because, yeah, a kilometer is 10 miles, you've done 5, so you've done half a kilometer. So you do m over x to find out what your distance in kilometers is. But of course, the distance that you go is going to be directly proportional to the cost of the fuel. The further you go, the more you're going to have to pay. So we've got this kind of a multiplier acting as it is, right? In the end of this here, we're going to have an m over x like this, because it's directly proportional. So it's, cost is equal to k times this thing m over x. So we're going to eliminate anything that doesn't have an m over x. Then look at the next bit. A car uses 1 liter of fuel for this many kilometers. Now again, if you just pretend f is 1,000 here, if you use 1 liter of fuel every 1,000 kilometers, that sounds like a pretty good deal. The bigger f is, the less it's going to cost. Like if f suddenly drops down to 10, it's going to cost much more to go anywhere. So the bigger f is, the less the cost, which means those are inversely proportional, and f is going to appear on the bottom, because when you set up inverse proportion, you say the cost is equal to k over f, maybe. So f is going to appear on the bottom. And lastly, when you divide by, or if the cost is in pence per litre, and we want to work out what it is in pounds, if you have some cost in pence, you divide by 100 to find the cost in pounds, right? So if this is the cost in pence of something, you divide by 100 and find that's 80 quid. So we're looking for m over x, we're looking for f on the bottom, and we're looking at 100 on the bottom because we're dividing. So I think the answer is this one all the way down here. Although I honestly have no idea because I just winged that question. This question is nice. I've talked in a Tomorrow video before about how many solutions questions you just sketch. 100x is a straight line, and I know you're thinking right now, oh, that straight line is so shallow. It got such a small gradient. How dare you plot 100x looking like that? But you don't know what my scale is. Like, I haven't labeled the scale. 100x is just a straight line. So there's 100x. The tan graph between minus 360 and 360 does this, right? It does this, and then it does this again, then it does this again. How many intersections are there? 1, 2, 3, 4, and then 5. So there's going to be 5 of them. Good, paper done.